Did you know that a French man in 2016 was living a normal, healthy life without 90% of his brain? This isn't magic, this is just the phenomenon of cerebral plasticity.
Sometimes, when born or in their teenage years, young people might come across a brain malfunction or disorder. If the disorder seems to be only affecting one half of the brain and deals critical damage so that half of the brain is beyond repair, one may have to undergo a brain operation called a hemispherectomy, meaning that half of the brain will be removed. Take a look at the diagram shown. The half of the brain in red is the one affected by a disorder, and this side will be removed during the operation. You might think, however, wouldn't all the functions and memory stored in that half of the brain be lost? Not exactly, and this phenomenon is called cerebral plasticity. Cerebral plasticity is a process in the developing brain where functions and memories in a weaker portion of the brain can get transferred to unused parts of the brain, most likely in the other hemisphere if a disorder happens to affect only one side of the brain. Let's think of this in a mathematical sense. To put it simply, a hemisphere affected by a disorder is made up of helpful, important functions plus malfunctions that shouldn't be there in an unaffected part of the brain. In cerebral plasticity, only the good functions will be transferred to unused synapses in the other half of the brain, and the malfunctions in the diseased part of the brain will be removed through the hemispherectomy. So, what exactly are synapses? Synapses are tiny gaps between neurons that serve as a highway for tiny molecules called neurotransmitters, which deliver chemical messages from one part of the brain to another. If you look at the diagram shown here, the green and red dots are neurotransmitters, the unaffected and affected halves of the brain respectively, and the black dots along the edges of the neurons are receptors that are analogous to mailboxes, where the messages are delivered. Unused synapses have the same structure as the ones in use, except that there aren't any neurotransmitters passing through them. During cerebral plasticity, that's going to change, since the good functions remaining in the affected hemisphere of the brain will be moved to these unused synapses. However, there is an important caveat to cerebral plasticity because it can't just happen at all ages. Cerebral plasticity can only occur when the brain is still developing. That is, the maximum ages that it can happen are from 18 to 23 years old, the times when most men and women stop growing. When the brain is still developing, it can make some last minute changes before it stops growing. This can be illustrated when, for example, one has an assignment to submit by a specific deadline. At the deadline, the work done on the assignment must be submitted and cannot be changed once turned in. However, at whatever time before the deadline, anything can be changed. Finally, cerebral plasticity doesn't work in just humans. It also happens in other species of animals. In a study of a nematode called C. elegans, when the sense of touch was removed from the nervous system, the olfactory sense, or sense of smell, was heightened. Scientists are still conducting research regarding cerebral plasticity today. Could you be the one to fully figure out what's behind this phenomenon?